right. Okay. So next up, we have a pretty cool treat. Paolo is going to talk to us a little bit about our sister repository, KubeFlex. He's been working on this diligently over the past couple weeks. Paolo, please take it away.
Thank you, Andy. So let me just share my screen. Okay, so as Andy mentioned, KubeFlex is now one of the repos under KubeStellar. So here is KubeFlex. Let me explain what it is. So as you probably know, we've been working to have now this more general architecture for KubeStellar, where we have different type of providers for logical cluster, or now we are calling them spaces. And so KubeFlex is one implementation that somehow provides some kind of more efficient way to just create spaces rather than creating full clusters. The idea is to create only the minimum that we need, still using standard upstream Kube API servers. So pretty much it's a way to create instances of Kube API servers plus maybe selected controllers in a way that is relatively efficient. It's probably not as efficient as creating KCP workspaces, but it's somehow sitting in the middle between creating full clusters and creating kind of KCP workspaces. And here is the project. And by the way, the generality, I think, is more general than just creating API servers, because once we start creating also controllers, the idea is we can create, it's a way to create somehow control planes where you can also have controllers and Kube APIs for specific use cases. So that's really one of the, I think, values of KubeFlex here. So this idea of creating Kube API servers and maybe selected controllers and some CRDs, some APIs that are specific to certain use cases. Right now, we actually have implemented 3. And I'm going to go through that in the demo. The other point is the ability to select the type of storage backend. Normally in Kubernetes, as you know, you have etcd. Here, the idea is to provide more flexibility. For example, if you want to create a very lightweight kind of instance of space, you may not want to necessarily have to run also a dedicated etcd server for that, but you could use a shared etcd server with other spaces or other API servers. And you could also select the type of storage. For example, you could use something like Postgres, and we support Postgres as kind of default for shared database. The other point is there is flexibility also in the choice of API server builds. So by default, we allow you to create upstream Kube API servers. For example, right now we're supporting 127.1, but you could use different type of API servers based also on the use case or what you need. And finally, the idea is to provide this single CLI that somehow simplifies the user experience in terms of somehow setting up the environment for KubeFlex and creating control planes, etc. Even if you potentially can do everything with standard Kube CLIs, but this somehow makes the experience a little easier. So let's talk a little bit about the architecture before going to a demo. So as you can see on the right side, we have hosting cluster. So this right now in KubeFlex is kind cluster, but it could be potentially any type of Kubernetes cluster, because we don't really have a particular dependency on a cluster, except something that we do at least for the development environment of KubeFlex, something that it's easy to use as a developer. So that basically, for that we use kind, because that's widely used by developers. And so with that, we provide a way to somehow set up initially KubeFlex and everything in an easy way using the CLI. So in the architecture, we have a KubeFlex system namespace where we install an operator. The operator is watching these custom resources that are basically defining control plane instances, in the sense that, as I said, a control plane is essentially an API server plus controllers plus potentially some CRDs. And so the CLI, or even using kubectl, you can basically create an instance of a CR in the hosting cluster. These are cluster scoped, this CR. The operator will look at that CR, will watch the CRs. When one is created, is going to start looking at that CR and reconciling based also on the type of control plane, basically creating a namespace to host that control plane, create an instance of Kube API server. If it's shared database, it's going to connect that to the shared database. It can create an instance also of the subset of the Kube controller manager where there are selected controllers. For example, the garbage collector controller and other controllers that are somehow fundamental. But in general, it doesn't create all the things that you normally have in a Kube cluster control plane, for example, scheduler or other things like that, or many of the controllers that normally are associated with running pods, managing nodes, other things like that. Because we are really looking to create the most efficient somehow implementation of these control planes or spaces. So at this point, I will go to a quick demo to show the capabilities. I just want to mention that there are few releases already. We are release V021 now. So anybody that wants to try, if you're using Mac OS, it's pretty simple. If you're Brew, it's pretty much 2 commands. You basically create a tab. You basically add a tab to your Brew installation and just install KubeFlex. All it does is to essentially install the CLI. And once you have the CLI, I'm not going to show the step because it takes a couple of minutes. All you need to have is a kind cluster. Actually, kind install, not even create a kind cluster because KubeFlex will create a kind for you in a way that is already pre-configured with the ingress and everything that is needed to run KubeFlex, and plus installing KubeFlex operator as well. So if you run this command, essentially, it's going to create a kind cluster, and you end up with an environment that is ready to run, to create control planes now. Okay, so let's go to a demo. So I already have installed the latest KFlex, and we can take a look to the commands that we have. So you can create a control plane instance. That is the main thing that you pretty much can do here. Once you create an instance, typically what happens is that the KubeFlex CLI will switch the context of your current kubeconfig to point to the new hosted cluster, or the new, hosted control plane. So you can use this command ctx to switch back and forth between control planes, so going back to the original hosting cluster and so on in an easy way. Of course, you could do that also with kubeconfig, set context, etc. But this makes somehow things a little bit easier. You can also delete a control plane, and the init command is mainly to initialize, as I mentioned, KubeFlex. That is to install KubeFlex on a cluster that you have. If you have kind, also we create kind, we set up ingress with all of those things. If you have another cluster, then this will pretty much install KubeFlex, but you still have to set up ingress and other things. And those are typically specific to the kind of Kubernetes you are running. Okay, so let's just try now to also check which version I have and if this is connected to a cluster. As you can see, I'm connected now to a cluster because I already installed KubeFlex. So I have a kind cluster when I'm running this, and the cluster is the hosting cluster is a 127.1 cluster running kind. Indeed, if I do kind to get the clusters, I should see that I have this cluster KubeFlex. So now let's go ahead and create a control plane. So all I have to do is to create control plane with a name, for example, CP1. And what happens here now is that, first of all, the KubeFlex CLI will somehow save the reference to the current context that I'm running. It's going to create, if we go back to this picture, it's going to create an instance of the control plane CR. And again, this is something I can do also using a standard kubectl command and the YAML for the control plane CR. But the CLI somehow make a little easier because after the control plane is created, is also checking, as you can see, is waiting for the API server to become ready. Once it's ready, also, it will retrieve the kubeconfig for that particular control plane that is stored within the namespace for that control plane. Is actually in a secret that contains the kubeconfig. It will retrieve it from the secret. It will merge some of that in the existing context that you have, similar to what you have when you're actually using kind. For example, if you are familiar with kind, you know that when you create a kind cluster, the kind CLI will automatically get the kubeconfig for the kind cluster, is going to set in your current kubeconfig, is going to also set the default context to that kubeconfig. If you create another kind cluster, it's going to do the same. It's going to get the kubeconfig, it's going to merge into the existing kubeconfig file, it's going to set the new context to the new cluster. And then you have to, basically, you can switch between contexts. So KubeFlex does something pretty much very similar. So whenever you create a new control plane, we retrieve the context. The kubeconfig is going to merge in the existing kubeconfig file that you have, is going to set the new context to the one of the new control planes. So right now, if I look at what I have here, let's check out. Actually, there is a command. I use another command just to see which one is my new context. I use this kube context, but you can also look at this using the standard kubectl commands. But you see that the context is now the CP1, that is the name of the control plane. And indeed, if I look at the namespaces, as you can see, I created previously this namespace my NS. Actually, I created this previously. I had this from before. So let's actually look at this, right? I'm here now in this context, and now I want to go back to where I was in the hosting cluster. So if I go KFlex CTX, this is going to bring back the context to the original context. If I look at the namespaces here, as you can see, I have a namespace here, the CP1 system, where I'm running the CP1 pretty much control plane. We have the API server and everything. Indeed, if I look at what is inside that namespace, I can look at the pods, for example, minus CP1. I have actually two pods. One is the API server, and there is also the controller manager that is not running the full controller manager of the standard Kubernetes that you get in a Kubernetes cluster, because we don't need all the controllers if we're not creating pods or managing nodes or doing other things like that. We have a minimum set that is typically used in Kube API server for example, garbage collection or other things like that. So those are the few controllers that are running there. And as you can see, there are actually two containers in the Kube API server. One actually of them is a kind container, because I'm using a shared database. We can take a look to the shared database. If we look at the namespace KubeFlex system, there is a Postgres database that is a shared DB, as I have in my picture here. Right now I'm using the shared Postgres database. And so this particular control plane is using that shared database. And if I create another control plane using the shared database, it's going to also point to the same shared database. But as you can see, the other point is, in addition to the API server, the kind container, there is this controller manager, but there is no, for example, scheduler or kubeDNS, core DNS, pods, or other things like that. So we really try to minimize as much as possible this control plane footprint. So let me actually go back now. And another feature I like to show, of course, I can create another control plane, right? Let's create another control plane just for demonstrating this. For example, creating a control plane CP2. And this pretty much will do the same thing, right? We'll apply a control plane CR, this time with a different name. It's going to create another namespace, as we see here. So basically, this is all done by this operator running in the back here in this KubeFlex system namespace. And once the API server, as you can see, takes a few seconds to get the API server up and running. And now I can check here As you can see, these are different from the other that I had before, where I had this my namespace I created previously. Now I don't have that. And pretty much I can interact now with this control plane the same way I normally interact with a Kube API server. And now I can switch back to CP1, for example. I can easily use this KubeFlex. Oh, sorry, not create. I just want to use a CTX CP1. So now in the other context, I can see, but you can do the switching of the context the usual way, right? So now one other feature I'd like to show is that so far what we have created are sort of standard Kube API servers, but part of the power of also KubeFlex is to be able to create different type of control planes. And by the way, if I switch now back to my hosting cluster, I can see that I have, if I list these control planes, you see that I have these two control planes. These are CRs. And you see there is a type K8S. So this sort of the default is creating pretty much, as I mentioned, a Kube API server plus controller manager and stuff like that. So let's say now that I want to create a different type of control plane that allow me as a developer in this hosting cluster to, for example, create pods. And there is a project in community called vCluster that does pretty much that. And we have also integrated with that. So we can use pretty much the same plumbing, the same infrastructure. Actually, I'm going to do that now to create different type of control planes like that one. So if I do create, for example, a CP3 now, and I say type is vCluster, I will show that this is a slightly different type of control plane. There is a little more, in terms of footprint because he has also a DNS, core DNS server. He has a little bit more things. He has also a kind of a syncer. This is all part of the vCluster kind of control plane. But I can do some other thing that is, I think, quite interesting here, right? So I'm here now in this new control plane that is of type vCluster. You can see that now I have by default these namespaces. But the cool thing about this is that I can do like I can do something like run a pod, for example. Let's see if I can do that. Nginx. And the pod will run in the hosting cluster. So let's say image Nginx latest. Okay, so this created a pod. And by the way, I cannot do that into the other type of control planes that I had, like the K8S, simply because I don't have their controllers to run pods or stuff like that. In this case, what happens in the vCluster, and I invite you to look at vCluster if you're interested, is that there is a syncer that essentially synchronizes the pod to the hosting cluster. The pod actually runs in the namespace of in the hosting namespace in the hosted cluster. So let's take a look to this pod I just created. You see the pod is running, right? This reminds, some people may remind a lot the feature in KCP of using a syncer, having a backend cluster to do this. The cool thing about this is that now I can also do things like exec into that pod. For example, exec -IT Nginx, and let's see if I run something like a shell. Sorry, it's -IT. Okay, so the name is actually pod Nginx. One sec. I think I have Nginx. Let's see if I have done something wrong. Let me try something else. Okay, Nginx. Yes, so I can take logs from Nginx, and I should be able to do exec. I'm not sure why. Exec -IT. Probably I misspelled something. Okay, so maybe it's something that I'm doing wrong. But anyway, the point is, in general, this part of the way vCluster works is that you can also interact with these pods. You can do like exec, you can do logs, you can do the usual stuff that you do. And if I, just for showing what happens when I go back to the hosting cluster, where is this pod, right? Someone may ask, where is it, right? If I look at the pods in the namespace CP3, you see that there is this, first of all, there is the vCluster. This is really the API server plus Syncer plus some other stuff that vCluster has, and there is a core DNS. So this is a little bit more heavyweight than just running the pure API server, the way I'm doing now. But there is also this pod. This is the one actually created from the inside the vCluster, right? And now, of course, what is the use for this, right? It's mainly to give developers a way to create pods and to basically have their own kind of cluster and run stuff in this hosting cluster. But the main reason I'm showing this is to show us actually the flexibility. That's why it's called KubeFlex. So KubeFlex, in terms of creating different type of control planes, it possibly integrates with other projects. One last thing I want to show before finishing is that using the same pretty much approach I just used to create this vCluster, I want to create a different type of control plane now that is OCM control plane. So OCM is Open Cluster Management. There is also a set of APIs for that that may be also interesting for us in terms of possibly building some kind of integration with that, maybe some front end using some of those backend APIs, for example, for inventory or registration of clusters. This works pretty much the same way, and is using also a lightweight version of OCM that is part of their project that is called the multi-cluster Open Cluster Management Control Plane. So it works pretty much the same way. The only difference is that I'm providing a different, basically, type of API server. Now it's ready, and if I look at this, again, I can list the namespaces, but the interesting thing is that I can look at CRDs, and you see I have all the CRDs, in this case, of Open Cluster Management. And I'm not going to go through that now because of time, but I could actually use that to register, for example, a kind cluster and show that in my inventory and other stuff like that. That could be maybe for another demo. But anyway, at this point, I just wanted to show the basics of KubeFlex. And of course, other possible extensions here is the ability to create control planes that support certain type of APIs. So, for example, I want to provide a control plane to manage cross-plane kind of APIs, for example, or maybe Knative kind of APIs, etc. The idea is really to sort of run the controllers needed by those APIs and provide somehow the ability to run this in your control plane. Another point maybe for future that we've been discussing also with June. June has been looking at KubeBind is can we sort of run something like KubeBind in this environment in KubeFlex? So the idea is that in KubeFlex I could have providers. I could have maybe some of these control planes could be providers of APIs where they run the controllers. For example, imagine a cross-plane provider, and some of these control planes or spaces will be consumers. So if we manage somehow to put that together, then the idea is I could create a control plane, maybe a K8s control plane, import APIs from a provider, and then start pretty much consuming those APIs, all in one kind of environment. I see that. Okay, so that's pretty much all I have to show. Let me unshare. I'm going to open the floor for any question or clarification. Again, for those that would like to try, it's pretty easy, right? So as I show, if you have a Mac, it's especially easy. It's pretty much brew commands, couple of commands, you get pretty much everything set up and running.